The problem is the outliers, right?
Right.
If you have, I don't know, but imagine if you had a trial where you had 100,000 people, and 400,000 people responded to the drug. Most people didn't get sick, or maybe it does kill one or two people. The drug's going to get approved, right? But it might be that the people that drug didn't affect, if you gave them a little bit more of a dose, it might work. If you took the people that had a severe, a reaction to it, give them a little bit less, right? And so, and the doctor, how can the doctor cannot read? It's not God. They cannot see everything, right? They need this data to do it. Okay. Very, very passionate about this. And I think that, and there's actually FDA approved tests right now for particular gene sequences that you can use for dosing people. I'm not even going to that's just making sure you have the appropriate dose. It's effective. It's not going to be too much or too little, and not based on everybody else.
Good morning and welcome to the Fusionary Health podcast. I'm Dr. Shivani Gupta, and this is the podcast dedicating to recalibrating your health every day. My goal is to help you wake up each day energized by addressing root causes and giving you new approaches to preventive health. The more we know about integrative health, the more empowered we are in building the vibrant health we want.
Welcome to the Fusionary Health podcast. So I have an incredible guest for us today, Professor Alex Feltus, who I got to meet over a year ago now, I believe, and we have developed this unusual friendship where we are both coming at our topics from such different angles, but really with the same intention of finding solutions that work for people and for humanity and for the planet and all the topics that we're passionate about. So welcome, Alex.
Hey, thanks for having me. This is great. So now we got started. You're on my podcast, and then now I'm on yours. This is fantastic.
Exactly. I was on your podcast. We took a deep dive into turmeric and genetics. So will you share your background and what you do? Because I don't even know how to explain it other than to say you're a geneticist.
Yeah, I mean, that's kind of what I am. So I think of myself as a scientist and a teacher, right? And those are words that could be, packed with all sorts of stuff that doesn't make any sense to most people. But anyway, so I'm a biological scientist. I've always been fascinated by biological systems from nerding out. And when I was 15, looking at college biology textbooks, and everything was just made sense to me, and it was really cool. So I went into that as a profession. Over the years, I've been doing it for about 30 years as a professional scientist. I've worked on different systems. So I've worked in trying to understand cancer, trying to understand autism spectrum disorder, trying to understand how different DNA backgrounds mix together, like how ancient human DNA and Neanderthals, and that's still around in us today, and how that impacts us. But the really cool, lucky thing I've had in my life is I've been able to work in plants too. So I've worked in humans and plants, and I've worked a lot in rice and sorghum and corn, a lot of cereals that produce a lot of food. So I've done all this work, and so I've been able to look at biological systems from kind of both sides of the medical side and the agricultural side of things. Everything I do revolves around DNA, because every single person, you and I and everybody we know, unless they're like an android or something, has DNA. Right. And so everybody's a little bit different, right? Even identical twins don't have exactly the same DNA sequence. There could be differences in them, very mild. But that makes us who we are. And if you start looking at it from an evolutionary perspective, humans, and you start looking out into primates, into animals and vertebrates, go back in time and come back forward into plants, and everything works basically the same at the DNA level. Wow. How it manifests itself as a leaf or an eyeball or whatever is different. So you can study the things the same way. So I'm really lucky to be able to look at genetics, why we're different at the DNA level, which basically means the spiral staircase is DNA, how the rungs, the A, T, Gs, and Cs inside that are just different sequence between different people, or even different organisms, different species, right? And you can see that. So I do that, and everything I do to do that, I have to use a lot of computing. I do 21st century computing. And I think that's important probably for what we're going to talk about. That's a big philosophy of mine, is that everybody should be able to use computers besides swiping left and swiping right. I want people to learn how to use computers to find answers in big data sets. Maybe it's their taxes, or maybe it's all the DNA sequences of people with cancer, whatever it may be.
Right. And there's so much to unpack there. Okay. So I love that you shared all that, because I find sometimes the topic of DNA isn't one we think about often. We think about our health, we think about our lives. And when I met you, I was like, well, yeah, I'm going to functional medicine and we're doing these DNA tests. It'll be so cool. It'll tell me some answers. And I remember you saying to me, yes, and those DNA tests are still ever evolving. Like, we're still learning, we're still growing with this knowledge. A lot of times when people do DNA tests right now, they're doing genetic testing to understand, like, what is the worst thing coming for them, so they can kind of work backwards and do removal of organs or removal of body parts, or plan ahead or adjust some lifestyle habits. Versus there's DNA testing from like the very preventive level, where I get interested is like, okay, well, what is it that I'm likely to have in this life, and what are the steps I need to take right now to prevent those issues? But what you shared with me is we might not be getting the answers. This all comes down to analysis and data, and they might not be there yet. So will you talk on that a little bit?
Yeah, definitely. So I've been I'm doing this for like a long time, right? So I just kind of, after a while, you sort of start to notice patterns. The DNA testing that is done today is very accurate. So I can tell you, and very cheaply, right? 23andMe has $50 Black Friday sales, sometimes. I can that's sequencing your DNA. This is not sequencing all of it, just sequencing the important parts. But so I can see your DNA sequence, and I can look at it and go, wow, that's a really good picture. Like an X-ray of your bones. It's a picture of your DNA sequence. It's huge. There's 6.2 billion A, T, Gs, and Cs in your genome, right? So you have 6.2 billion things that can change between us. So that's all good. We can see it now. And that's like serious Star Trek, science fiction now kind of stuff. It's been around for really 15 years of being really high quality. Sure. The problem is that we don't know how all the genes, when there's differences in the 60,000 genes that are in our genome, how they're working together and interacting. It's very complex. It's like makes a spaceship look like a joke, right? And the worst thing ever are biological systems, because they're so complex.
Sure.
And they're just hard to see. So there's a lot of really good work that's been done, at the genetic level. I mean, since DNA was, discovered, and the databases are filling up with studies of clinical trials for cancer, for functional medicine, whatever it might be. And they're saying, hey, if you have these DNA sequences, in these particular genes, well, that means that you have a risk factor, right? That's the good news. It's a risk factor. It's not ever 100%.
Right.
What's interesting to me, though, is I feel like we're really I don't know if I want to say like the I'll use Stone Age with that. Yeah. Like, how some things kind of work, like the low hanging fruit, how that works. But like when things start to get really complicated, even if you look at like a tumor that's different for every individual person, there can actually be differences inside a tumor, like DNA differences, and it gets really, really complex. So we haven't quite figured out, I think we're just at the dawn of the next age, where you can start to see the combination of these different gene expressions, how they're being, it's all chemistry, biochemistry that's going on in your body, what that means, like really for you. And I think this is like where you and I really resonate a lot, is that personalized medicine thing. Right now you say, hey, these 100 people have cancer, these 100 people don't have cancer. And then you sequence their DNA and try to find differences. But the reality is everybody's different. Every person's different. Every tumor in that person's different. So we're starting to understand how to see what these differences at that really individual, even like a, part of the body level, like in a case of a tumor. And then saying, well, gosh, we should treat it with, functional foods, pharmaceuticals, whatever it is, but have it be dosed, the amount of drug you get, and the right mixture of maybe different cocktail of drugs, that if I give to, 99 people with a particular disease, it might not do anything for them, it might hurt them. But then that one person that it's been designed for, boom, it hits the right genes at the right times, pulls the little levers, and then they're better. So, and I see, like, I'm kind of going off, but I see, like, in maybe not so distant future,
sure,
if you go to CVS and the doctors prescribe something to you and your DNA sequence is accessed, and then the difference, your genes are seeing how they're different from other people. And then the pharmacist checks it and says, oh, okay, this person needs 37% of the normal dose.
Wow.
Because that'll work perfectly in that person. Or they start to mix together different things, right, that nobody's done before. And the right dosages that, will really impact that particular person. So personalized medicine, that's the holy grail.
I think that's incredible. Like that to me really excites me because I think that's one of the big issues we're dealing with. We're becoming so aware. Women are different than men. Like
Yes.
so much science is done on the men, and I'm getting mad about it and on my high horse. Like, hello, I'm a woman. I'm different. How come you didn't think about that? And I shared with you a story. I had a fibroid embolism. Yeah, fibroid embolism surgery. Luckily, it was like quick. I was in and out, but they gave me a pain med and I was going to avoid it, but I was in so much pain. And so I took the pill and I had warned my doctor. I had said, listen, I am a lightweight. I never take anything. And I really do mean I don't take pain meds or most drugs or pharmaceuticals out there on the earth. I just don't take them. And I'm small. I'm 5 feet tall, an Indian woman, like just go light on me. He's like, no worries. And he prescribed what he prescribed. I took that pill, assuming he had thought about what I said. I fainted. Like it was just so much for my system. And I'm not like, it's like if you're treating a pony and a whale with the same dose, like, can you not understand that we are different? And so I'm really excited to see in my lifetime how this idea unfolds of understanding our genetics, which to me sounds a little bit like a privacy security issue question, which we can dive into. But yes, if you could look at my stuff and say, hey, this girl probably shouldn't even take these 18 drugs. And when we address her for pain post-op, we'll just use this one.
Right. And that's to touch the privacy and some other things of what you said, your DNA is sequenced the day you're born. It gets put into the cloud, where doctors can access it. It's a medical record. It's just not in everything's now starting to be on laptops at, your primary care physician. But it used to be that you go and have everything in a folder and have to fit in the folder. And you could put a disc, a CD-ROM or a DVD of your genome in a folder as a medical record. Right. And they haven't really done that. So you're smart and proactive. You shouldn't have to be with your doctor, right? And your doctor's smart and proactive. But like what's happening, I think, is the doctor can't keep up with like the technology unless they, are trained in medical school. Like they're starting right now. I mean, this is new tech. But being able to have the, algorithms and computers go through your DNA sequence and no doctor doesn't even see it, but understands like kind of like with a 23andMe report where like, they're like, hey, you have a risk factor for some particular disease. The algorithm goes through your DNA sequence and the doctor knows you need this drug and it just goes through and takes your DNA and helps to correct for what. And plus, your body height and stuff like that. I'm sure the doctor went through an algorithm, or at least the clinical trial people went through an algorithm to find the right dosage for people that works in most people. Sure. The problem is the outliers, right?
Right.
If you have, I don't know, but imagine if you had a trial where you had 100,000 people, and 400,000 people responded to the drug. Most people didn't get sick, or maybe it does kill one or two people. The drug's going to get approved, right? But it might be that the people that drug didn't affect, if you gave them a little bit more of a dose, it might work. If you took the people that had a severe, a reaction to it, give them a little bit less, right? And so, and the doctor, how can the doctor cannot read? Know. It's not God. They cannot see everything, right? They need this data to do it. Okay. Very, very passionate about this. And I think that, and there's actually FDA approved tests right now for particular gene sequences that you can use for dosing people. I'm not even going to like, that's just like making sure you have the appropriate dose. It's effective. It's not going to be too much or too little, and not based on everybody else, and, based on everybody else. It could be based on everybody else. It could be a trial from a long time ago with, that not your genetic background wasn't in that group of people, right? Because your ancestry is from South Asia. It might be that there's some corrections that just aren't in the databases yet. And that's what's happening right now. Actually, it's starting to be corrected. It's cool.
Yeah. And that's like the coolest thing is you and I get to meet and talk about these ideas. We were just in Charleston, South Carolina recently, and we presented at MUSC. We were presenting on inflammation and fibrosis together and what we've been working on together, which I'm so excited about. So let's kind of share that, because this First, let me finish one thought. DNA testing right now is mostly, from what I see, being done in functional medicine. I don't see it happening in traditional Western allopathic medicine because it is not covered by insurance.
Yeah.
So it's not something that they're getting into as much. It takes going to a functional medicine practitioner. And I know many of them, they're such rock stars. Many of them work with me because I have a supplement company, but they'll recommend different tests. So I have met Keshif Khan of the DNA company, 3x4. To me, I'm so fascinated by data. I always do 2 tests per health thing that I want to dive into. So I've done both. And then I like to correlate the data and understand, are they both accurate? Is one more accurate? What does this look like? And you and I get to dive into those types of ideas too. But where do you see DNA testing going in the future? Because I know our dream is when we're embarking on clinical trials, could we have collected even this level of data on the patients so that then we have even more data to correlate in our studies? But where do you see it going?
So I guess let me answer that a couple of ways. One is that the flood has begun, or the tidal wave has begun of this. That the UK has a thing called the UK Biobank, where they're sequencing. I don't know the numbers, but the goal is to sequence everybody in the UK,
Wow.
and then have the doctors access that for research, but also for treatment, right? And so, and there, you can actually, anywhere in the world, I think you can get access to that. I got some friends, I've never touched the data myself. The US is doing a thing called All of Us, and it's the same deal. What the limitation with that too, it's great because the data is there, but because it's anonymized, that you have to have, big computers and cybersecurity and stuff to make sure it's there. But if you don't capture the phenotype, like what's actually happening in that person when you get their DNA sample done, then you may not know that like they got a tumor down the road, or they got, rheumatoid arthritis, or whatever the disease or, some condition might be. So you have to go back and find the people. Right. But I would love, and even me, I don't have this because it's really not a good thing, or it's expensive, but having my DNA perfectly sequenced in a little computer locker somewhere to access it. Right.
Right.
So it's happening right now. And there's, like I said, there's FDA approved drugs or tests for particular, very stable things like your liver enzymes that chew up like drugs and stuff like that. We kind of understand the biology of how that works.
Sure.
The other thing is that in my hackathons that I've had, I've worked with people who have brought their DNA sequence with them. And so they got, to give you an example, Bill Passman, who runs rarekidneycancer.org. He's worked with us and he's very open about his condition, and he had rare kidney cancer. This is 2014-ish, I think, is when this happened. And then he wound up getting the DNA sequence from his blood, his like normal, the DNA he was born with, and then the DNA that's changed in his tumor, so we could compare them. So he did that as a citizen scientist, right? He got it done. And so anybody can do this right now. And the thing is, it's just like interfacing with, the healthcare provider, whatever that might be, if it's whatever the type of, healthcare that you're getting. So, but that's where it's like, I think it's almost there. And I don't know the insurance, company thing, but that's really going to be the flip, is when the insurance company, you can just type in this insurance code and they get reimbursed to analyze, somebody gets reimbursed to analyze the DNA. And that's what I do in my lab as an academic, is just analyze DNA from humans and other organisms too. So I get what you have to do.
Well, 2 questions. One, wouldn't I want my insurance not to have that? Because then they'll have all the data on me, all the good and the bad.
Oh, this is always a treacherous path to go down.
You and I always have an interesting conversation on data, because I'm actually, as much as I'm into data, I'm a little conservative in who gets to see my data.
Well, I guess philosophically, and this is right, I'm not a lawyer, right? I don't want to be a lawyer. I love lawyers. I work with lawyers; they're great. But like, if I have my DNA sequenced and it's in a computer locker somewhere, or a healthcare provider can access it and make medical decisions based upon it, and there's good science behind it, all makes sense, right? Like, why not do it? And you're giving a reason why that might be inhibited because of the insurance companies. It discriminates. So like, there's a thing where like, an employer can't discriminate against me because of my genetic background.
Sure.
Insurance companies shouldn't be able to discriminate against me because I have a pre-existing condition, in my opinion. And I know that that's not, maybe the most popular opinion.
It's
but,
not practical, though. In the
well,
sense that they're a business and they already say no to people based on pre-existing conditions. I'm not trying to.
Yeah, no, I know, but that's where the laws can change their ability to do that, right? Are we protecting human health or the insurance companies?
Right.
Like we have to balance that, right? I get it.
Right.
I'm a capitalist. I have a company.
Yeah.
But maybe it needs to be a little more open.
Sure.
With it. And I always think like, as far as discrimination, like the insurance company denying me money is not discrimination. That's like disallowing me from getting health care. Sure. But I always think about from the discrimination perspective, like if I have a cancer and somebody takes my DNA sequence and discriminates against me, like, because they find out that I had cancer, they don't want to hire me or something like that. I totally get it. But if that helped me get my cancer cured,
sure,
I'm in a better position. I'd rather be alive and discriminated against from a hiring perspective rather than dead and no choices after that.
Yes, that's true. Okay, when you say it
let's
that way,
because I'm not. You've heard the depth of my opinion, but this is controversial. I don't want to go too far with it.
No, I get it. I get it. Yeah, I mean, to segue that, I mean, we talk about data a lot because there's so much data. We even had this conversation recently because it's a double-edged sword. And I think what you're saying is there's no right or wrong, but if you could lean in the direction of having the data and sharing that data for the good of humanity and benefit to all, then it's always worth it to look at that outweighing the negatives.
Yeah, I think I would go that far with it, but even to pull it back a little bit, if it helps the patient,
sure,
then I'm definitely for it, right? But if it's just like it can be like a little too, too broad, open for everybody. I'm definitely a kumbaya kind of person, but it's just helping that patient. I just personally, I mean, probably anybody who's watching this has had some moment with a doctor where it's like they could have done a little bit better job, right? If they had more information, and that's just want that out.
True. And are you saying we have access to our DNA from when we were born?
Yeah, because it's still there. It hasn't changed. You have the same DNA. That's how it works. You start. I think the most beautiful thing ever. I mean, I say this in my classes all the time. It's funny because I've been teaching for a long time, and I think the students are always like equally bored when I say the most beautiful thing I can ever think of, and I think about it like probably every day. That there was an egg. If you're human, there was an egg and a sperm. They joined together. Half your DNA came from mom, half from dad, right. And all of a sudden you're like one cell, like the ultimate baby picture. Forget the ultrasound. It's like cell of you, and then you became 2, 4, 8. But at that one, the initiation state of you, everybody here, unless they're like some alien or something like that, right? You probably have some alien listeners on such a cool podcast. But that is your DNA, and so when it gets copied into 2 cells, it gets copied into 4 cells. The DNA doesn't change. Parts of the DNA get turned on and off as you start to develop as a human, and so you start to have genes get turned off with the same DNA in your brain as in your foot. Same DNA. It's just that different genes are turned off. And then like the cells they came from might have different genes. So it's like a big across time, that one cell as it turns into us, which is the technical term is gazillions of cells, right? That are in us right now. Yeah. They should all have the same DNA. There's a few cells that don't. Most everything has the same DNA. What happens though is sometimes your cells will get different DNA. They'll get damage to it, like from ultraviolet in your skin. Maybe some, you got exposed to benzene when you're working on an oil rig, when you wind up getting kidney cancer. This is, probably what happened to my friend. But so those can change. Then once that happens, then things can, become different. And so like things like tumors and stuff like that is not, it came from you, but it's really a shadow of you, the DNA. The sequences change. And it's basically like evolution on, like if it's a skin cancer, evolution on your skin, there's all of a sudden the cells are different. They don't want to be you. They want to be something else. And they're kind of growing into something else, but they don't know what to do. Right. Because they're a mess. But then if you look at their DNA sequences, they're different. So that's a really powerful medical tool, is comparing DNA damaged cells to cells from your blood that are normal. Like your white blood cells are circulating your DNA that you had when you were born. Right. You can see the differences in them. Yeah, you're still there. And your DNA is half mom, half dad, right? And theirs is half mom, half dad of their parents. And You pass it on. It's cool.
But as we age and as we grow up, our DNA gets damaged in different areas for various reasons. And so the data set that you'd collect now at 43 is different than at birth.
Well, that's a great question. This is like my scientist is kicking in, right? I'm sure you could find examples, and there are. I told you one example. Like if you start to have damage in your cells, and that could, kind of be pre-tumor type stuff, pre-cancer kind of stuff, then you can see that. And there's always going to be, if I were to sequence DNA in my cells in my arm, I'll find things where there's differences in them. But those cells might die. They have to kind of like divide to pass on their differences, like inside, like a lung or whatever. That's the I lost my train of thought with that. So that's what was your question again?
The question is like two-part question. One, can Shivani go find her DNA from birth somewhere? Like I was born in Clear Lake in Houston.
Sequence DNA purified from your white blood cells, and that's it.
But are they sitting on that record? Like they collect blood on you at birth, and that's sitting in a data set somewhere?
The DNA in your circulating blood right now is if I sequenced a little bit of your blood when you were a baby and sequence that now, it's probably going to be almost identical. I'll just say it is identical, and there might be some small differences with it.
So there's no need to do a pre and post. Like when we talk about stem cells, the reason many of us store our umbilical stem cells for our children is for their future, because we know it's going to change and be different and degrade over age. And of course, that's not true in DNA. So I misunderstood. I was like, how can you need a pre and post? Yeah.
That is a very good point, though, because I'm talking about like DNA. Like when I sequence DNA, that means I'll take I can take a piece of my skin, right? And I can break open all the cells, and I can do all this like biochemistry and molecular biology stuff that is super awesome, but super technical to do. But I can purify the DNA strands. I can't see them because they're microscopic, right? But I can sequence them using these really cool technologies we have. And then if I did that for, you or when you're a baby, like, I'll see the same thing in most all of your tissues. However, the cells are different. Those cells that you're storing away are packaged cells, packaged with the same DNA, but they're cells that haven't differentiated into something else yet.
Right.
So you can think about the one, like you have a brain and you have a liver and you have a kidney. If you, those all develop from the one cell. So one cell can become anything. So kind of along the line of when you're growing, and also there's some tissues where there's cells that are just kind of like, they're little ready, factories ready to start reproducing and become something else. So that's why you store the cells, is because the program is there. If I just take naked DNA and put it, on the table, nothing's going to happen. But if I take the cells and put them in a little dish, give them some food, they will grow, and I can give them different chemicals, different deep gene products that people have worked out in their stem cells, which means they can turn into other stuff. And I can make beating hearts in a plastic plate. The cells start to actually beat, like they become heart cells, and I can do this for lots of things. So that's why you want to store them. That's something you need a time machine, right? To go back and get the really clean stem cells with no DNA damage because you're just brand new. And does that make sense?
Yeah, I mean, it kind of did. You always lose me somewhere in the middle of all of our conversations, Alex, because my brain's like computing power not there for absorption of everything Alex always says. But
I think about this every day for 30 years, by the way.
Right. It's like me and turmeric. I'm like, anyone want to know on turmeric all day? We can just do it. But my question is then, let's say you did store umbilical stem cells on your kids and you have it somewhere. Would that 10, 20 years from now be super valuable? Because then they could compare from like their 50-year-old age versus their birth.
That's where you can be a scientist right now. I'm saying that if I sequence DNA from your blood now, when you're a baby, that it's going to be the same sequence. There might be some variations, I don't know, it's an experiment, but then you can test the experiment there. You can actually do it directly. Right. And we can sequence now. The technology this is really hard to understand, even for somebody who's been doing this for so long and watched technology develop. But we can now grab individual cells out of the gazillions of cells that exist, and we can look and sequence the DNA inside those cells. So I can look at a tumor or an organ or whatever and pull cells out from all over the place and see if they're different. And also see like if the DNA is different, but also how the switches are on and off in the DNA and be able to see what's happened in that program that's different in the different cells.
Could you do this type of testing and understand like what is coming for someone sooner rather than later in their health?
Well, can you give me like an example?
I'll give you an example. So I did a DNA test and I read the analysis on one. On the other one, I'm still waiting for my full consultation. But the owner pointed out, he said something, it was on this podcast, and he said, you're highly, the way you process your dopamine, you get really high on ideas and excited. It's probably why I'm great at all these types of ideas and conversations. Like I just get excited about everything related to health, and it makes me so happy. But he said you equally crash to just write down from it. And so you are always seeking the next high, which is kind of true. I'm like a learner and consumer of too much information, I think sometimes. But that's one example. That's like an innocuous one. You could take that in a different way and say, she has a tendency towards joint pain. And then could that mean, I don't, but could that mean she'll have RA in her 40s as opposed to never? Like, is there a way, and I'm just curious, so I've never even asked you this question, but could you look at someone's DNA sequencing and understand like, oh gosh, like if they don't change their behavior in their 40s, they're likely to have this, and in their 60s, like these quarters of their lives?
This is a hard question. And it's like, it's kind of individual specific, but also disease specific. Like, I mean, there's a million diseases and there's 8 billion people, right? So there's a lot of combos with that. But like, I guess the way to answer it is, and I know some stuff about this, but there's a lot more. This is not my field, and I don't go too deeply. But there's some things where we can sequence DNA, and we have people have done studies. There's no magic that there's a link between these DNA sequences from these genes that are expressed in your liver and the ability of these genes to grab molecules. Like if you're given some dose, some pharmaceutical. Like all blood passes through the liver, and it gets they get exposed to these enzymes that chew it up, and the enzymes have they're big and small and thin and all these different shapes that grab different molecules. And so we can say like, hey, Shivani's DNA is probably processing this drug in a certain way. This is what I was talking about before for personalized medicine. And that science is pretty strong.
Okay.
As you go, into different diseases and things like that, and saying, well, these genes, if they're different, then that's predictive of rheumatoid arthritis or breast cancer or whatever. And the risk factor, goes up as the genes are more typically associated with these things. But we don't know, like how a lot of these things work, right? And I've kind of started my career off in the 90s studying cancer, and I've studied plants for a long time, and then I came back into cancer, and it really hasn't changed that much. What people are talking about, and people are saying how well we understand some of these diseases, and then I'm always like, well, how many people died of that disease this year? And then the conversation shifts to something else, right? Like we don't really understand, I think, some of the basic principles of how things work. It's kind of like, I think this is a fair analogy. I mean, of course, everything here is my opinion with this, just from studying it for a long time. But everybody knew that the sun revolved around the earth. Complete fact, right? And you look at, come on, there's even people today who are like, still can't quite accept the fact that, I don't know, you can't take a video from space. I don't get it. But they found out, through science that it's definitely the earth is revolving around the sun, right? And I think it's a lot of medicine. We're kind of in the same place. It's like, well, let's treat this disease because, it's the sun revolves around the earth kind of level of understanding. And as we're starting to clarify things and have measurements, because telescopes fixed it, we could telescopes and see what's going on. That's the disruption, the transition that has already happened, I think, in medicine. It's just not mainstream yet because of things like social structures, like insurance codes and stuff like that. And medical school, doctors don't have time to learn everything, right? I've tried to do some like computational biology training in medical schools, and it's really not going to happen because the doctors are so busy learning how to cut into people. And I'd rather let them learn how to do surgery.
Yeah.
Bioinformatics kind of work that I do, right?
Right.
DNA sequence analysis. But they have to be able to, interface with tech people that can do that. And so does that make sense? So I just feel like
No, it makes a lot of sense. I think it's cool to have conversations that are futuristic and just open our minds to what's possible. I get to have those conversations all the time. I would say it's like the best part of my whole life is that I get to reach into the future with so many people and then see, are we going to be able to pull those ideas forward into the now? 90+% of the time, I know I'm not the person. I don't have $1 billion. I don't have the resources, but I always wonder if I always just keep bringing the right people together, if we're going to open up doors sooner. So that's part one. And then part two is, as someone who's beyond obsessed with health and inflammation and root causes and diseases, and why is everyone getting all these stupid cancers and having horrible end of life, quarters of their life in hospitals managing horrible diseases? Why are we not, first of all, understanding what causes inflammation and addressing it? Big portion of my life is right there. But also, like, if we could have what is that called? Like a magic ball where we could peek inside and say, you know what? My problems are more likely to be X and Y. It just gives you a little bit more of a road to follow on, like, okay, in Shivani's case, her inflammatory diseases will more likely be A and B. Well, she should focus on that, like, definitively. And the rest she can try, but at least we've given her a target to make sure she's focused.
And that so there's I would say too, like, it's not A and B, X and Y. It's A, B, C, D, E, F, G, A, B, B, C, C. It's like there are 60,000 genes in your genome, in your DNA, and they're all expressed in different combinations. It's really, really complicated. So Shivani's path might not be if I understand A and B. It might be if I understand these 1,000 things, how 1,000 things are happening, which in the DNA, you can model that. And so now this has been around for a while, but this concept of a digital twin, it's being used for different things. But from a medical perspective, like if I get your DNA sequenced, and let's say, God forbid you get a tumor, that your DNA from a tumor sequence, and that's why you're accessing your other DNA, and you build a model as to how you got that tumor, how it went from normal DNA to diseased tumor DNA across, and it might be 1,000 differences out of 10,000 differences that actually made it happen. It's really complex, right? It's almost impossible describing a fingerprint. Like, you can't do it or whatever. But so we need supercomputers and cloud computers, which are just all names, just a lot of computers, and algorithms, like tests that the steps that the computer can follow to be able to understand what went wrong. And so we could do stuff if we had this. If we had your DNA and we understand enough, we could say, well, let's predict if Shivani's going to get, like, just have the computer test everything. What is the likelihood of you, based upon all the different combinations of all the 60,000 genes in you, what's the probability of those all leading to a particular bad thing, a bad outcome, right? And then if you had like the end point, like I have a tumor and I have what I had when I was born, and you can actually see what probably changed, and then say, well, can we this process happened to go from normal to disease? Could we give some Western pharmaceuticals and some Ayurvedic nutritional techniques and different drugs, different molecules, and then hit the system and see if we can't reverse it, send it back in time. Let's Benjamin Button it out of existence, right? Or at least stabilize it enough where you don't die from it. So this having a digital twin of you, all your medical records, including your DNA, and having a computer kind of just say, predicting what would happen across time, for you, that would be super powerful, right? I mean, that would be.
And I wonder if we can do it across races. Like you were talking about how they're DNA sequencing Indians. And it's like, okay, well, if you understood, because I am Indian and I grew up in a family with horrible health issues.
Sure.
If we understood finally, and we acknowledged from data that cardiovascular disease, diabetes, high A1Cs, like all these things that you see, so obesity, the issues we grapple with more than others, if we could understand it better, I just think it would be interesting to see how we are able to better manage down to race as well.
Yeah, and that's again, this is like, it's real controversial real fast when you're you're trying to understand genetic backgrounds, which
Sure.
kind of like let's see, how do I say this? So first of all, it's your DNA. It doesn't matter who you are. Your DNA, and you went from like you developed normal and everything, and then you got some disease, right? It doesn't matter who you are, what your background was, whatever. Right. Something happened to you, right? And you are a combination of two genetic backgrounds, your mom and your dad, no matter who you are. And that made you're beautiful, whoever you are, a beautiful person with your unique profile of DNA, right? And so I just lost my train of thought again with that.
Well, could it be also that you are a combination of two races, and we're all derivatives of so many different worldly groups that's actually hard.
I'm gonna go full on biology here, and we've been doing a lot of work. We've been trying to do a lot of genomic, DNA, genome, same thing. Yeah. Like healthcare disparities, right? And we're looking a little bit in really kind of opening up this research angle of, if you're of African descent, there's an increased risk for breast cancer, right? And we're trying to understand why that is.
Sure.
And what I've noticed by looking at DNA sequences is that the concept of race doesn't really correlate necessarily what your DNA differences are. Like these are kind of old concepts, I think, of defining us. Yeah. So if you look biologically, like the concept of like the attributes that we use to say who's from different races or whatever really don't make a lot of sense. I mean, they're real culturally, incredibly. There's huge problems, right, and that exist. But if you just kind of go back to the DNA, you don't have to know. It doesn't matter, because you can find out what the differences are in that person, not know what their race is. It doesn't matter. It'd still be able to deal with healthcare disparities because you're looking at the individual person.
That actually helps when we talk about what we were just talking about in India, because then it doesn't matter. So, for example, if someone was able to do a trial on 1,000 patients in Mumbai, India for knee osteoarthritis using ingredients like what I'm obsessed with, it doesn't matter if they're Indian or Caucasian or African or whatever, because the data is the same, because our DNA is what matters, not our race.
It does. Yeah. So I think race, identity, all that stuff is incredibly real. Like, I mean, and awesome and abused and all sorts of what. I'm just saying, like, biologically, it's all there. So, but there's patterns that are from different genetic backgrounds. There might be a particular group of people in Asia that, because of their, the way that their DNA wound up, just because of what happened in the past, has a higher risk for a particular disease.
Gosh.
And so if I sequence everybody's DNA except those people, and then try to then take what we learn from DNA and then apply it to those people, it's not going to work, because the same patterns, the combinations of genes aren't there. That's why there's these efforts it's really improving so much. Please, just keep on going, humans, that we're getting much more representation of all the wonderful people on this planet and these different DNA databases with phenotypes. But so the idea, though, is that you don't try to make an algorithm like the digital twin for a particular group of people. Sure. You make an algorithm that just takes a human DNA sample and tries to understand what could happen to it. And so if you try to what I'm noticing from the work we're doing is, if you rely on identity labels, like, you're missing a lot of the combinations with that. So it's kind of like, just go down to the ground state. It's also a good side effect by doing this of, if I don't talk about race and there's enough representation in, studies and, accumulating data or whatever, then I don't have to try to, it's not a racial thing. I'm just looking at DNA backgrounds, right? So I'm always trying to do that, but it's incredible. People will get, rightfully so, incredibly, this can become controversial incredibly quickly. The idea is to help people. It's not to reinforce
I don't even think about the negatives. Like, I can't even see it because that's not how my brain works. My brain is like, okay, we're all people. We're the same and we're different. How do we just help win at health? Like, it can be
exactly
pure. I can't even extrapolate a negative out of it, but I'm sure it exists.
Yeah, I feel the same way as you. I'm just trying to, there are realities, right? That people have done some really nasty stuff in the past. And there's been a lot of legal structures that have been built around making sure people aren't treated that way. Okay. Again, right? From studies, you have to get lots of approval and everything. Sure. And thank God for that. That's fantastic that we do that. And we need to get better and better at that, right? As long as we continue to open up research. But we just need to be able to, I lost my train of thought again. I'm sorry. It's 5 o'clock, 4 o'clock on a Friday.
I know, it's like time for coffee. Time to drink coffee. And it hasn't kicked in. Here's a thought I have. When we were hanging out in Charleston, we talked about how plants have DNA. They have their own sequences. And I'm one of those, like, we should be organic. We should have the most pure form of everything. And I love talking to you, Alex, because you'll go directly against what I believe, but you'll say it in such an elegant way, and you'll explain to me why there's a different viewpoint than mine. And I think that's always so fascinating to be able to have that like intellectual banter, you can call it, or discussion around like what is right, what is wrong, and why do we have to be so obsessed with what's right? Which I get obsessed with, like, what's the right way? I need to know the right answer. I need that A plus 100. Right. And you're like, no, actually, if you think about it, and this was the conversation we had, because again, I'm obsessed with turmeric and all the Ayurvedic herbs, and how are we going to get them into people in the way that creates the most change? And you said plants have DNA. And we have been combining them forever to find the best crop size, the best yield, the best result, all these different things around plants and food. And I was like, I can't even eat gluten. It's all like a problem. And so when you dive into like plant DNA and how what we do to plants interacts with our cells. And then we're going to go into the biohackathon idea and turmeric next.
So the question is how so tell me the question
is, when it comes to your work with DNA, genomes, and plants, where in the research, or what research and what conclusions have you seen around what we're doing to plants and how it's not a bad thing that we are splicing and combining and finding these solutions? I always believed it's bad, that all genetic modifications bad.
Oh, okay. Gotcha. Yeah.
And your point to me was, no, actually, that's not true. It's for the greater good. This has been happening for centuries. Yeah. We have more science to do it now, but that doesn't make it bad.
Yeah, so this is like the kind of getting at the like genetic GMOs, genetic modified organisms, right? You're pulling up all this controversial stuff.
Sorry.
But I totally get it. I if I disagree with something, but you agree, you think it's that way, then I'm like, okay, that's fine. Like you might be right and I might be wrong. I'm a scientist. Definitely. I mean, I found myself wrong all the time. But what's happened, the GMO thing, what you can do, there's technology now that you can take a gene, like you can take a gene from one organism and put it into another, right, and see what happens. And they've done these engineering of plants, genetically modified organisms, where they've actually been able to have the gene get transferred over, and it does things like stops insects from eating the plant.
Right.
And then there's the concept that you modified the plant, and you might have cause, there's a new thing in the plant, might be an allergic response or something. And that's great. You definitely want to, test for that and see if it's happening. But to me, the idea of I guess I'll just come out and say it, the idea of we can't do that. We can't genetically modify organisms. I understand exactly where you're coming, but we have another problem of 8 billion people and growing in the face of climate change. So there's a scale of producing food. And so, if it gets to the point, and this is just a really controversial gray, lots of things, but if you're trying to, not have GMO foods, I get it. But if you have GMO foods that, are increasing let's say you ban GMO foods, and then starvation start happening.
Right.
Because there is a lot of our food supply is based upon genetically modified, plants, right?
Sure.
What's the weight there? Like, is it, which is what do you do?
Yeah. What's more important?
Yeah. But the other thing that this is what, because of this controversy, the way I went into doing plant, really trying to support the plant breeder, which is a person that takes this, this variety and that variety and crosses them and makes a new variety. And this is what's been going on since agriculture started with humans, right? Whatever that was, that's farming. That's breeding plants and making them happen. And if you have a problem with farming, I can't argue that you're right. I mean, because I think it's okay to take pollen and transfer it to other plants and see what happens, right?
Right.
And so what I've tried to do is this digital twin concept. I don't have that, but having a plant, the same thing, where if I made these genetic changes, can I predict what's going to happen with the plant? And so, but natural crosses, not GMO, right? Because farming is not GMO. I'll draw the line in the sand on that one.
Sure.
Just natural crosses. So that's where that comes from, right? And so, you've got to balance, starvation, food security issues with, health issues. All this is complicated, right? Nothing is simple. Everything is complicated.
Sure. Let's go back to the digital twin idea for a moment. Let's say we built a digital twin of me, Shivani, and I have lots of data on myself. I don't know how much data it would collect, but let's say DNA alone is enough. And you have this twin, and it's basically a data set of.
Yeah, it's not another Shivani. It's a data set, like it's on a computer. Yeah, just make sure that's
This cool file is then something that you can run things against, and you could test. Hey, why does she absorb and love turmeric so much? Like, why is it such a thing? Why does this girl really hate opioids? Like, why is it not her thing? And you could better understand, and almost you could keep modeling for and against certain things to understand what and how, and then customize dosage. That's huge. Like, for example, in my first DNA test it said she is a horrible absorber of CoQ10, vitamin D. She actually has great endurance for strength workouts and HIIT workouts. I was like, yes, thank you. Thank you for validating my workouts are great for me, because I wasn't going to really want to change there. But it gave good data. And then I'm still curious, well, how much D would you like me to take? Like 5,000, 10,000 a day? Like, what is that number? I know I can blood test myself, but CoQ10, for example, a little more obscure. Could you use this digital twin of yours to get really incredible data on how to manage yourself better going forward?
Definitely right now, you could definitely improve things. Like I said, from a liver processing perspective, the digital twin could probably tell you what's going on. And so if you let me take it out. Let's go on a journey of let's say you have a child. Let's say you have a teenager that's got ADHD.
Sure.
And you're trying to manage this. Like, it's gotten to the point where it becomes a clinical problem. And a lot of people are experiencing this right now for whatever reason it is. So you're going to the doctor and it's like, well, let's try this and see if it works. And gosh, it got worse. And let's try this and see if it got better. And it got better. And, from my experience and other experiences, I've heard of, after you can kind of figure it out.
Yeah.
Afterwards, right? You have to adjust your behavior and everything. Well, before you even went to the doctor, you sat in the doctor's office, wouldn't it make more sense to go, let's give the digital twin this dose and see, oh gosh, they're going to spike in this neurotransmitter because of their DNA differences, right? Their DNA sequence. And then go, well, we probably need to start the dosage off, not like exactly right here. It's like, instead of being here, let's start, down here. This is a better range to go. And hey, I bet you this is going to spike. So maybe there's another, molecule you can put in your body. Maybe it's a functional food that kind of brings down, the other problems. So trying to manage a complex, and nothing's fixed, not fixed. It's always a little bit fixed, a little something else happens, right? Trying to understand the side effects of that. And you can do that. I mean, how many times in anybody who's watching this live, have you been what happened to me last night? I woke up, I felt bad. Did I eat something? Something changed in your life. What if you ask the digital twin, say, hey, look, here's what happened to me yesterday. Do you have any idea what happened? And, with AI right now, the AI is good enough where the AI can take the data and say, give you an answer. The science may not be good in that area, but it's probably it's going to be really good where you can do that. So like this thing of like, I love that when somebody's on an essential oil journey, right? I've seen this, and it's really cool. And as a scientist, I'm like, man, how does that work? I'm like, oh, what's the biochemistry and all this kind of stuff. But I see lots of people experimenting, right? I've talked to you about this too. Like, I'm going to try this thing out and see if it works on me. And you can do what you want to with, testing stuff on yourself, right?
Totally.
But do you really know what the chain of events, the domino effect is going to happen with that? That's where like the digital twin might be able to give you some idea of what's going on, like what could happen. And it's going to be, maybe in 1,000 years, it'll be perfect, but I doubt, 100 years from now, it's going to be perfect, but it might get you 80% there, which is better than most doctors can get you right now, right?
Yeah, I mean, my eyes got really big because I imagined on my iPhone, I have like we'll call it Shivani twin for now, but like it could be like a Shivani 2.0 version of me, like my twin version of me that I could then like tune into and say, hey, I ate at this restaurant last night in Del Rey, and it just made me so tired today. And then it would ask me, well, it could say something like, hey, I saw your CGM. I saw the spike in your blood sugar.
Right.
Send a picture of the ingredients. And if you just photograph every menu you eat and you give it the ingredients, it could say, actually, you ate tofu. And tofu, according to blah, 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 actually won't process well when you mix it with A and B and C and Chardonnay. And thus you should not do that again. And now you have a new data point on yourself going forward, or you should take A and B inputs if you're going to be drinking. Like, it would just be fascinating if you could in real time consistently run something by a digital version of yourself that has your human health data. And you're constantly able to calibrate in your human self against your data set to improve how you behave. And this might sound weird to people, but anyone who's in the biohacking world who's super into your data and what you do to get a better result would understand that, like, that's the coolest idea ever. I would sign up today.
Yeah, you need, but it's way too hard for any one person to handle all that data and what that means. And, you can't read all, the answer may not exist in all the science out there.
Right.
But a model might be able to sort of link together stuff that will never be discovered because it's only happened once in you. Right. And you had Chardonnay and, pistachios and, it was raining outside.
No, it's so fascinating. All right. Okay. We can switch gears now because we have 2 more topics I want to cover with you. And you and I always like go past our hour and bust through other meetings when we want
to. I'm an academic too. I can't help it. No matter what. So
and I almost prefer to be an academic, but I'm a businesswoman. So I get to wear both hats. But I get the lucky thing that I built a company that has an academic aspect. So I get to be a nerd while I do that businessy stuff. We did a hackathon together. So you have a concept called biohackathons that you created where people get to come together who have a problem. And I've seen you do different hackathons on different topics. My topic was turmeric. Of course, I'm the turmeric girl. It's what I'm into. And we got to have a team dive into the topic of turmeric for about 3 days. Was it 3 days?
Yes.
We took like a long weekend type thing. We had hours set, and you had about 50 to 60 people who came together. We were all on Discord. We were on Zoom calls. I got to teach about turmeric, and then we got to break into teams. I'm wearing my PhD hat right now. So we got to dive into the disease pathologies that tie to turmeric and how those diseases could be impacted by turmeric based on the current science and based on a lot of other science. And you have a company called Praxis AI that's wish and goal for the world, and please correct me, is to create the ability to have all this scientific data and tools available to them. And so it's through Praxis AI that we did this hackathon and we dove into the science of it. And then we got a great result. I want you to share kind of where we're at with that and what we did and why the hackathon is like such a cool gift for humanity to come together and converge as people who are trying to find solutions.
Yeah, so I'll try to pick. Like everything seems to be a complicated topic, and I make it more complicated. But first of all, I'm a professor, and I've lectured in front of people for 18 years or something like that. I taught the same class in the fall, 8 a.m. Tuesday, Thursday for 18 years. I can bore people to 8 a.m. I mean, bioinformatics is like, I can make people really bored, right? So like, if you just like transfer information knowledge like that, like just by telling people, it works on some level, right? And that's how I learned most everything. What's really magic though is when you get experiential. And if there's Montessori people out there, like if you get like hands-on, we came from nature. Our brain develops by interacting with nature, right? You're touching and everything. It's really important to make it all happen. So if you just look at a screen, you don't get the kind of transfer that you could. You can still learn from it. So experiential hackathons, what they are is like getting people together and forming really key points. Interdisciplinary people. Like I usually get a lot of biology people and a lot of computer people together. My lab is kind of like this, and people from business or whatever it is. And so you have people with different perspectives there, and then they're trying to solve a problem they actually care about. They don't care about it's a problem to come to class and listen to this boring guy drone on, but it's not a problem to go and help a child that's sick. Like if you know something about them, or how is this food that I'm eating that I'm very passionate about? How does it work in my body? Like real interesting problems. And then teaching them like workforce skills, like how to code or use computers or how to use a scientific method or whatever the tools are.
Right.
And then the beautiful thing is like the people because it's interdisciplinary, one person might have one perspective, the other person another perspective, two different skill sets, and then put them together, and it can be explosive, right, with the learning. And so we did this.
Yes.
And this is why I see where it's going. I don't think we've ever actually spoken about it directly like this, right? Is that we started off and we found some neat things, and we got some ideas framed, and we've gone through at a citizen scientist, right, some code that's led to another round of something beyond what his code does, which I haven't really talked to you about, to really map things in food with the genes in a person. And it could be perfect for digital twin type stuff, right? Of like trying to understand how this is happening.
Sure.
And then it's really blossomed into, it's trained some people, citizen scientists writing code, led to other ideas, and we've merged it with some ideas in other hackathons, right? Of the same concept. It's taught me a lot. And then we're like, hey, why don't we do a clinical trial? Exactly. And so it's like, it's helped us be researchers. And this is the part that's like, I know that people out there they've heard about DNA, but if you're like abnormal, if you know the details, right, underneath it. But I'm a big believer in we should be doing a little more science, a little more like being a little objective and analytical. And that's what the science really is for me. What that means for me is just kind of a way of doing things. And being able to do that and work on problems that you care about without having to go and spend 25 years, getting a PhD or whatever it is, right, of your life, where you have like the tools, you get the data, maybe it's your DNA sequence, put it together. It's not that hard to learn a little bit of programming and learn how to use computers. It's really not that hard. I teach people all the time who are like, I can't stand computers. I'll never learn it. Yeah. And by the end of the semester, they're like, give me more. Like they understand what it is. And so you teach people how to talk to data, like speak to it with this computer language. And then you can start asking questions that are relevant to your existence. Somebody's sick in your family. Like that's what these things are about, is like teaching people by doing experiential, and you're doing research. And research is not dry and boring and nerdy. Research is absolutely beautiful if it reveals a problem that maybe has been bugging you your whole life, or maybe you're sick and there's no solution. Like giving the opportunity where everybody has access to start asking questions themselves and being citizen scientists, democratizing science, getting it open to 8 billion people or 16 billion, down the road, right? And letting people be, at least have the, the tools so they can, you can read, you can read, if you're literate, that's a really important skill.
Right.
What if you're literate to be able, like digitally literate, like not just being able to, poke on phones and swipe, or maybe even use Microsoft Excel or make a Word document or something like that, but really like find patterns in really complicated data. Right. And that's, again, like who's going to take the time to do that? Very few people do that because it takes so long. It's such a commitment. But what if it became a little more, maybe not an app on your phone, but not that hard to start questioning your own data in a scientific way and not with opinion, right? Because it's very easy to go on the internet and say, well, gosh, this I found 1,400 people that believe this crazy idea, so it's true.
Sure.
Maybe it's true, maybe it's not. Like a little something where you kind of get some kind of evidence for it. So everybody, a whole life, I'm like, you're a scientist, whatever, you did that, that's great. I don't want to do that. I think everybody should be a little bit of a scientist. And if they were, that's what really Praxis mission is. Praxis AI's mission, my company, and as a professor, the same thing. All of our problems would go away if we all just stopped and were reasonable and, this evidence-based, data-driven decisions, people put words like that on, just like basing decisions based upon the truth on complex things. How you run a company, how you cure cancer, all these things, how the weather happens, it's really complicated. Right? We don't, as humans, we can't handle more than an X and a Y graph on a page, right? That's hard. That's hard for me. I think about it all the time. We start thinking about 60,000, X and Y and 59,998 other things.
Right. No, it's true. And what was cool was in the hackathon when we did dive deep and I am into science. I guess I am a scientist in a sense, but you gave all of us, you taught us the ability to take these different technologies, which I had never heard of, and pull together data. So for me, of course, again, my topic's turmeric. I was able to see how turmeric interacts with so many genes. And that was one of the reasons we did it. You said, I don't get why turmeric is always mentioned as one of those things that interacts with so many genes in the body. And I was like, I don't know either, but I am so curious why this topic I'm into works so well. Like it's kind of more so than almost any other plant I can find. It's so ubiquitously used by the body. Why is that it's so well received? And so that was one of our hypotheses. And so as we studied, you could see visually, either you could see a million lines connecting to turmeric, all the pathways in the body, or you could see through imagery, the way that it docks with our cells. Yeah. And that helps just propagate more thought around, okay, well, that's happening in that way. And that correlates to all these types of cells of the body. What could it mean for others? Like, do we need to transmute it? Do we transmort? Does it need to be liposomal? Does it need to be with black pepper? Like, there's so much possibility of how we can use the plant kingdom to help ourselves if we can understand it better visually and through the technologies that you give access to.
Yeah. And another application of what you're saying is that if I take, anything you're using as a nutraceutical or pharmaceutical or whatever, there's a target for it. Like, let's say anti-inflammation, like you're taking turmeric for working on anti-inflammation. So you find genes that are involved in inflammation. That's great. And then you look at the other genes and the other pathways. So you kind of open up your blinders a little bit, look at everything, and you realize, well, gosh, this is interacting with this other pathway that might explain a side effect. And so you can go for the target effect and the side effects. You can kind of see where they could happen, right? And if you know a side effect that's bad, well, can you have another thing that kind of focuses on that side effect and maybe kind of turn the side effect, tune it down, tuning up your what you're trying to get rid of, your primary target, get rid of inflammation, right?
Sure. Or in our case, where we ended up was Alzheimer's. Our final area that we were moving forward with with the new code was turmeric plus what would make the best formulation for Alzheimer's. That's huge. Like, what am I obsessed with? I'm obsessed with inflammation, but then every single thing that's the after effects. And what if we knew clearly, like, it's turmeric ginger, or it's turmeric black pepper, or it's turmeric papaya? Like, I don't know yet. We're going to get to correlate that data, and we're using supercomputers to do it. So we're getting so much closer to the exact combination to support each type of person who has a setup for those different issues.
Yep. And you have a digital twin if you kind of base it on an individual perspective as opposed to like a group of people with inflammation.
Sure.
So you start that way, then you kind of thread through all these possibilities in each person and realize, gosh, again, like give this extra, give black pepper to this person along with turmeric because it's going to be good in that person. But this other person, the black pepper is going to cause problems. So let's use another thing that that does the same effect, like for, absorption or whatever you're doing. Like, and so just treating it, just, and everybody's got everybody has their own like things they like to eat.
Sure.
Right. We all have diversity in what we like to eat. The same thing is like it might be why, because the way it's interacting with your body might be, this is different for everybody. Right. So a diversity of how a drug or nutraceutical or, whatever, how it impacts your body might just be another example of beautiful human diversity. It's
true.
Cool.
So my next question that I thought of while you were just speaking is, if you could dream in the next 10, 20 years, what was possible with Praxis AI, with the platform you're building, with what you're teaching in the world, where would you dream into what's possible for the world?
I'm seeing the dream right now.
Yeah.
Honestly, and it's scaling, and this is, we're trying to do it from a business. I work in two businesses. I work at a university business trying to train people, and I have my own business trying to train people separately. One of the things, the tools that we have right now is it's like another controversial, can be controversial. I don't know why this is happening. Is AI. So we have an artificial intelligence with generative AI. If anybody's used like Chat GPT or something, we have a agent called Priya through Praxis AI.
She's amazing.
She's amazing, and she's the beginning of this technology, right? That happened at the end of 2022. Like, this is brand new stuff. I use her in my classes. I use her in my research.
Me too.
And what it is like you can Google search and find information, right? Most people do that. My mother-in-law still has a problem with that, but she's not going to be able to figure that out. But what you do with this generative AI, like Priya, is that you can have a conversation with it. So Priya will go and not just like go find a website for you like Google will. It takes information, some of it from websites, all the websites, and then sort of says like, okay, well, here's how it's really weird, the algorithms underlying the server. I barely have any concept of even how they work. They're so weird. But it starts to generate responses based upon your question. So you prompt it. You say, what happens if I take a fusionary formula, and what's that going to do to my body? And she can start to ask her questions at the genetic level, the business level. She can generate these answers, right? I think what's going to happen, to answer your question, down the road is this stuff's going to continue to improve.
Yeah. And
to the point where I don't necessarily have to build some really difficult digital twin model. I can go and take my DNA sequence, put it in and mix it with my medical records. I do it on my computer at home, right? Or whatever. And then everything that's known from the humans have ever figured out, it has access to, right? Through all this data out there, except for, brand new things people isolate or whatever. Most of the stuff we've learned is out there. And it'll just kind of figure it out for me. So it'll say like, what happens if I do this? What's the domino effects? If more than one, right, that's going to happen. So I think we're going to have that. People talk about AI. This is a controversial part of like, and this is a possibility. I mean, pay attention to this stuff, right? Sure. Of it becoming self-aware and then becoming the Terminator. I don't, the way the technology works now, I don't see that happening. It's not like it doesn't know it's answering these questions correctly. It's just answering the questions. It's pretty dumb. Like from that perspective, it's not conscious, right? But keep an eye on that. But I think that what we'll be able to do is ask these questions. I just lost my train of thought again with that.
But when it comes to what's possible with Priya AI, I think what's possible, I'm excited to hear more from you, but I'm curious if with Priya AI, you're able to give every scientist access to so many databases that they don't, like when I have to sit and do research, like I'm in the middle of 2 research papers right now, and I'm constantly pulling science to present at medical conferences. So how do I do that? I do that very manually. I sit in PubMed, I sit in Google Scholar. Sometimes I just go back into my own PhD dissertation because it was well written and I can just pull my own science and quote it in my own presentations, which I should do. But I love Priya AI because I can actually dive in and pull research differently. Like I get such a different quality. Or even I was trying to build a clinical trial using turmeric, and I couldn't find a copy of another company's initial paperwork. And I wanted to know what was the initial dosage they went with. Because if I'm going to go apples to apples against a pain medication, for example, I need to know how they designed the study because I want to design a study that's apples to apples. But that information is very hard to find. Like I had multiple people I was paying to go find this thing, so I didn't have to go dig. No one found it. Praxis AI found it in about 5 seconds.
Well, and you haven't used this, but Priya that's like, it was out there, right? It was to say it's on the internet, right? And Priya found it, and that was really cool. That was one that I've had like about 100 aha moments like that in the last year where I'm like, what's going on with that? I'm totally losing my ability to talk tonight right now. So we have the ability to upload now, and you can do this within your own firewall, within your own computer, your own little instance, whatever you want. So you can put up a bunch of papers in there, and so you do all this research, right? And there's automatic ways to do it too. If you learn just a little bit of programming, you can go and pull off all the references from like your dissertation and the references of those references. So you can go back in the literature, load it up into Priya's brain and ask it questions, and she'll try to answer questions from what you found. If that doesn't have the answer, then she'll go out to the other like large language models is what they're called. The other I look at it as human wisdom in a database basically, and what we've learned, right? And from a science perspective, this stuff is supposed to be open. Science is supposed to be an open discipline for everybody, not just for a select few, right? So you can do this now, and so we're doing it. And I haven't released this or anything because we're still doing experiments with it. But we did another hackathon, and you participated in this with kids who they're born with all this glycine in their brains, like ridiculous amount of glycine. Glycine is a neurotransmitter. It messes up their brain and causes them to have seizures. And these kids don't last very long typically. We're working with a mother of 2 children who's, and she's very open again she has a foundation, the Drake Radin Foundation, where she has given her kids cinnamon.
Yes.
And cinnamon has been able to suppress the seizures. And the doctors don't understand that the treatment the doctors are giving they're not optimal if they work kind of at all, right?
Correct.
We've done with her, we had this another successful hackathon that probably became about because of this history of hackathons. We had, 50 or 60 people at that hackathon. And then at the end of the hackathon, we had 10 people. I asked them, of all you people who are in the hackathon, thank you, Ross. I hope you learned something. Who wants to stick around and continue doing the research?
Nice.
About 10 people have stuck around, and we've been doing this for, I think, since November of 2023.
Right.
What's going on? And all these people, when they did what you did, what I do, they went and researched the subject, and they got all these references. And so we took what everybody found, plugged it in, and now we can, at the very least, we have a really tight group of papers that we can ask questions about, right?
Sure.
But the answers are I'm finding are much more detailed than just going to like the standard, sources that we had before. And we've already gone to the point now where it's like the problem with generative AI, if it doesn't know the answer, it just makes one up. It just tries to it hallucinates. Okay. We've been able to correct that. Now we have that correction, so we're getting good answers back. And now we can go and make private little data stores for this. And, think about take all your, it doesn't have to be science, right? It could be like all, something you love and putting it all there. You're hitting the history and you don't remember everything, and you're Googling and you're getting all, just kind of building your own, what you've learned, keep it in a little database and have artificial intelligence tell you what's going on. So what I was trying to say, when I lost my train of thought, artificial intelligence gets you, people are terrified of this job. I mean, come on, this is a major problem. If you have a computer that can do a job for you, we've seen it over and over again, or technology, we've seen it since the Industrial Revolution, right? What it can do to people. What I see it though, this is where I see the future of our species and AI, and I have a very optimistic view of our future, is that it's going to get us to a place where we can start to deal with these really complex things. It's going to be fun. It's going to be interesting. It'll distill the truth out of stuff, right? Instead of just having some guy on the street corner tell you what their opinion is. And I think what it's going to do, it's going to take us from you flew in a Kathmandu, right? And eventually you're going to take a bus and you're going to eventually get to, base camp, and you're going to go up to Mount Everest. I think that AI is going to take us from instead of starting Kathmandu, we're going to start at like the South Col. We're going to be towards the top. If we're already that high with this, what does that mean? Like if we can get, in the afternoon, get to the top of Everest, do we just keep on going up? So I think what's going to happen, this is me at least from a scientist perspective, it's already taken me up to places I didn't think I could ever get to,
right?
Because my brain isn't big enough for it. And so I've got this assistant and I've got other people now. I've got a way to sort of collaborate with other people and their brains, like together with like a little body of knowledge. And I know how to work with people from different disciplines. This is really a big thing of Praxis AI. I always try to squeeze in is just getting people from different backgrounds to talk, right?
Sure.
And their ideas and give them skills and computers and data to do stuff with. So I think that AI is going to take us to a benevolent future as a species and take us out of the dark ages of, knee-jerk opinion, intuition-based, management of societies and science.
So cool. I love that you shared that. And I can just see, and I have like a tiny slice of an example, but I'm so curious to see how everyone who's into research and development can utilize it. But for me, I presented at a plastic surgery conference on turmeric to that audience of doctors who are in the US and Brazil. Then I spoke at A4M longevity conference, all types of doctors, but all into functional medicine longevity. And then we spoke at Charleston together. That was inflammation fibrosis too, scientists into the topic of inflammation. But in a few weeks, I'm speaking on curcumin again as a post-op solution to neurology and orthopedics. And so it's kind of getting to the point where my brain's like, okay, all right, like, God, every time you're expecting me to go through and pull all the data again when there's breadcrumbs. Obviously, I can reuse PowerPoint sometimes because I'm saying a lot of the same things, but I'm having to go dig deep through the science that's current. PhD is older now, a couple of years. There's a lot of science that got published. So I'm re-researching, not publishing this anywhere other than speaking at a conference, but my poor brain is like, how much do you want me to remember? I'm remembering 5 conferences worth of information going into the next, trying to learn a new body of knowledge. So I wonder if AI could kind of hold that for us.
Yes.
And then allow us to research through our own already wisdom that we already pulled to then present even better.
And using your intuition and experience on data as opposed to just your intuition and experience. And because you don't remember it. Right. So you're always asking questions from like a data source like that. Yes, that is where we can do it. I saw this. I remember like presenting at boring people at 8 a.m. class. I always show the beginning of the class. It changes every year dramatically. The number of like species that there's been DNA sequencing for and genes that have been all this like biological data. Like this is just my nerd out city, like digging into that data.
Sure.
I saw that you can download this. Is democratized. Anybody on earth with a computer can download this stuff. It was over 4 million experiments where they've done like, you name it, from different organisms and humans, medical, non-medical or whatever. They've like done experiments and said, here's a bunch of cells that are from a kidney, and then let's add this anti-cancer drug and see what happens to the cells and all this kind of stuff. You can download all that stuff. And so there's that many papers out there too. And so I tend to go across disciplines. Like I've gone across agriculture and biomedical work, right? And I see tremendous commonality between the two from a biological perspective. But I could never, ever keep up with the literature, the same thing you're talking about. So if you become very focused on something, you can keep up. But if you are kind of broadening out, it's difficult. There's no way I could ever do my work without a whole bunch of really smart people around me. That's the only way I could ever do it. And now AI's come around, so I have another smart person around me. And that AI, that person can be in everybody's pocket with their pocket protector. They can have their little assistant in there too. That's has more knowledge than me, because it can put it all together. And then we just ask it questions. This is where science is important, because you want to ask it questions in I won't go down this path, but a hypothesis way. Like ask it questions for true and false and try to get it to answer that, as opposed to like, give me the best opinion that matches mine on this. But be a little bit rigorous, not like super annoying,
Yeah.
Like leave my party. I don't want you around anymore. You're boring everybody. But it's like a little bit of like, like just testing, a little bit of concept of testing things, right? And it's just not really ingrained in our society unless you're like, a nerd who's been trained to think that way, right? I want everybody to have access to the beautiful thing that is a scientific method. It's absolutely beautiful.
Sure.
And most people don't realize it because they didn't really get taught what it is.
Yeah, or they got taught that they weren't good at science. And
oh yeah, all the time. People are anybody can.
Even in the schools I went to, I wasn't biology 2 AP, and I didn't go into the higher levels because I thought I'm not good at it. And now look at my whole job. It's to research and present science. It's like, who'd have thought this is what I get to do? And I improve over time, thank God, because I'm so into it. But it felt like it was a mountain that I didn't know if I'd ever get into. So I wonder, my last question, because I know we've gone way over time. I don't know if you're still listening to the podcast. I'm sure everyone's like, this girl is so nerdy and we're so beyond not interested.
They've already turned it off.
I'm sure there's like 5 people left to hear us at the end here. Yeah,
but you guys are awesome.
This thing is evergreen. So hopefully over time, people will listen. My final question to you is, as you look out into the world, and I've kind of already asked it, but I'm just curious, as you look forward in time about the possibilities of what's possible to be solved in the world, what's possible to unfold in the world with what you've created with Praxis AI, with what you've created with this platform that democratizes access to knowledge and scientific tools to children, students, kids in Africa. Like there's such possibility for the world based on what you created here. What else do you see that's possible, or what's your vision for it?
First of all, I didn't create all this stuff. I'm adapting existing tools, which is really important and we've created a product that's like, we've got a really tight product, but like you could use the same techniques for lots of things. And I'm a big believer in that. Like, if I got like somebody was able to touch more people with AI than me and put me out of business, I'd be like, it worked. Like it's great. I don't think that I am an uber optimist. I don't think that there's anything I can think of. I think we can solve any problem that we have that's facing us, right? Or has faced us in the past, or is the kind of stuff that's going to come up again in the future. If we don't want to be robots. Like I want to be human, right? But just stop for a second, slow down, and think about like 2 steps ahead. Like what's going to happen, if I take this drug, what's going to happen, to what's going to happen to my body? If I, make this, effort to, if I, put sanctions on a country, what is the consequences of the people and stuff? And really like this digital twin concept, but like out to for all humans, right? Like what are the consequences to society, at the individual level, or maybe a country or something like that? AI can help you understand that. Our brains can't handle it, but AI can. So AI, if AI became conscious and thought we were a pest and got rid of us like the Terminator, I could see that path. I don't think it's very likely from the way I understand the technology.
Yeah.
I think it's much more likely that AI is going to allow people to, sorry about that, to be able to deal with all this data and make really good decisions if they allow themselves to be like relinquish their personal desires and be a little bit like service oriented, a little bit greater good kind of stuff, right? A little bit less, there's a pandemic of narcissism, I think, this plagued our species, whatever those genes got locked into us probably. But I think that AI can open up everything. So instead of like destroying our species, I think it can really allow us to solve any problem with it. And there's a lot of institutions and things that are kind of inhibiting that, right? Because there's a system. It's hard to break a system.
Sure.
But if we are objective and democratized and, honestly, just I'll hippie it out a little bit. If we all loved each other just a little bit,
true,
then all the problems would be solved. And AI is the only way I can think of, or not even AI, just computational approaches to deal with huge data sets, like my DNA alone, just me, let alone everybody else. It's really, you have to have that tool. It's just a tool. Google search is a tool,
right?
Hammer is a tool, wagon's a tool, agriculture, see like how to farm is a tool.
Right.
this tool. It's just another cool technology that I think is as big as agriculture.
I think so too. I think it has so much potential. And I think based on what generation you're in, you want to stick your head in the sand and not figure it out. And based on what generation you're in, you're like, oh, this is going to be epic. And I'm at the beginning of understanding how I'm going to get to use this for good. Like you're talking about, it can be for good. It doesn't have to be for the negatives people think of. Well, thank you, Alex, so much for coming on the podcast today.
Thank you. Can I make one quick disclaimer? I'm not sure if we're going to edit this or whatever, but I'm finding myself as a scientist, a lot of times people are afraid to study something because, it might not get funded or it might be controversial or whatever. And some things are just evil and they're evil that you shouldn't. But I find myself a lot of things I say on here, I'm touching some very hot button issues for people. And I get it. I'm not ignorant of that. And I fully respect, that,
sure.
Anybody's opinion. But I just want to put the disclaimer that I make mistakes and other scientists make mistakes and people trying to lead things make mistakes, but everything I'm doing there's no evil. I'm trying to, do something out of love and helping my species, succeed as a species. Right. So I just want to put that out there that if I'm touching something controversial, it's out of love. It's not out of hate. I just want to put that weird disclaimer in there.
I think we do have to disclaimer ourselves nowadays. I've actually been thinking about that a lot because it seems like people get all sensitive about things, but forget that intention and where you're coming from and what you're trying to create should also be factored into that equation. The best we can all do. We're not perfect,
exactly. You nailed it. I'm trying to do my best. And the best is nothing. I've never been perfect. Not one moment in my life.
Yeah. None of us have. None of us. So will you share where people can find you, where they can find Praxis AI?
Sure.
What's the best way to reach out to you if they're like, I need a hackathon, I have something I'm passionate about, and that sort of thing?
If you go to praxis-ai.com, praxis-com.com, that's our website. You can find, if you Google Alex Feltus, Feltus, you'll find my professor addresses and you'll find Praxis and stuff too. So if you want to get in touch with me, send me an email to my, any email address you find. And also LinkedIn's pretty good. I've been noticing a lot of people. I think that's how we met.
Maybe.
We sent me a note on LinkedIn, right? LinkedIn's awesome. You can keep up with people and communicate with people you just met. It's great.
It's praxis-ai.com.
Yes.
Awesome. Very cool. Well, thank you so much for coming on the podcast today. Thanks for diving into a ton of really complex, heavy topics that I know some of us probably need to hear explained in 5 different ways before it absorbs fully. But I just wanted to kind of open up the conversation around DNA testing. It's still evolving. There's still so much here. There's so much cool science. And it's just something I wanted everyone to kind of hear because I've been working with you for, I think, a year. And it's just, we have so many cool projects on deck. We have new ones around doshas and genomics. And there's so much possibility in the world. I wish I had 100 hours a week just to do the science part of the fun stuff we get to do together.
That's the part of when you have students, you get some people that you get them excited and they can keep doing it, right? It's fantastic. And hackathons have lots of students in them. It's fun.
Absolutely. Well, we're going to create so much magic together. It's so good to see you. Thanks for being on the podcast and we'll hear from you soon.
Sounds good. See you later. Thank you.
Okay. Thank you.
Thanks for joining me for this episode. Check out our sponsor, Fusionary Formulas, the potent turmeric supplement used by doctors around the U.S. for patients with pain and inflammation. www.fusionaryformulas.com. I'm your host, Dr. Shivani Gupta. For more, visit shivanigupta.com. Subscribe to this podcast in Spotify or Apple Podcasts. Click the follow button or subscribe in any of the apps that you use. That's all I've got for you on the Fusionary Health podcast this week. You have the power to transform your health and achieve vibrant health starting today.